Hey guys, we are back with the last and the final special type. So let us look at this particular example and then we'll see what is special about it. Okay, so far we talked about a unique solution, then we talked about no solution. Unique solution is where the lines intersect at a point, and then we were also able to see it from an algebraic perspective. And then we also talked about the no solution where the lines are parallel and we were not able to get a solution. The left hand side is not equal to the right hand side. Okay, now in this case, let us start by thinking about how we can solve this. Again, you are free to use any method you like. So what I'm going to do is, I can see there is a 2 here and there's a 4 here. So what I'm going to try to do is I'm going to try to make this -4 so that when I add these two, it is going to cross out. So how can I get this as, how can I make this as -4? Well, you can just simply multiply this by -2 and that will become -4 right away. Okay, so I'm still using the idea of this basic mathematical operation of multiplication, and then I will add it. So I can multiply both sides by -2. So it is -2 and then I put this in parentheses. I multiply the right hand side by -2 as well. Whatever we do to the left hand side, we have to do the exact same operation with the right hand side as well. So it's going to be -12, right? And if I simplify this, let us go ahead and distribute this. It is going to be -4x minus 6y equals to -12. So the first equation transforms to this one. And then I'm going to bring down the second equation, as we have been doing with any of these elimination methods. Guys, you have seen like here with all these three types, I'm using the elimination method. For me, elimination comes easy, but if you like substitution, feel free to use substitution or whatever you think is easier or convenient for you. Okay, so 4x plus 6y, x is aligned together, y is aligned together, and then the constants aligned together as well. Now, if I try to add these two equations, see what happens. This crosses out, there's a 0 here. Well, the second term crosses out, that happened in the previous type as well. But here, even the third term crosses out, so what we have here is like 0 equals to 0, which is true, right? The left hand side is equal to the right hand side. It is not like the type 2 where the left hand side was not equal to the right hand side. It is actually true. So when you get something like this, again, it is also a special case. Now what is special about this here is that this type of system is thought of as a dependent system. Because the two equations are basically like the same equations, and it is also thought of as there is, in this case, infinitely many solutions. So whenever you get this situation where your left hand side equals to the right hand side, and in this case zeros and zeros on the both sides, what we are looking at is infinitely many solutions. And it will make more sense when we actually look at this from a graphical perspective as well. And this is dependent system, and it is still thought of as a consistent system. Okay. Now, how does this look like when you actually graph it? I have an X, I have a Y. So the graph looks like somewhat like this. That is the graph of one of the lines, and if I try to draw the graph for the other line, it is actually going to be the same exact graph. So what is happening here is that these two lines are basically overlapping. They are overlapping. Guys, what does that mean? In terms of the solutions, so to find a solution for a system of equations, if you are trying to use a graphical method, you are looking for a point or points where the graphs intersect, right? So for our unique solution, they intersect only at one point. So that particular point is my solution. But here, both the equations are basically the same equations. They are equivalent equations. And when we try to graph them, they're basically the same lines. So when they are the same lines, they are actually intersecting each other at so infinitely many points. So that means that is the reason why there's infinitely many solutions. So basically, and you can choose any value for x, you can get a corresponding value for y, and any values, all the values are going to in fact work here. Okay, so here this is still a consistent system, but a dependent, and then we have infinitely many solutions. So to bring it all together, three systems, One, we have a unique solution, intersects at one point, and we have a one particular solution, still consistent. Then second one was, if we have parallel lines, they do not intersect, we have no solution, that is inconsistent solution. And then the third one is where basically the lines are the same, they are like just multiples of each other, right? If you see, like, if you multiply this equation by 2, you will exactly get the second equation. So they are basically linear combinations of each other, if you think in terms of the idea of linear combinations. And if you think in terms of a graph, they are like two lines overlapping each other, and when two lines overlap each other, they're basically intersecting at infinitely many points. That means we have infinitely many solutions. So guys, take a note of these three things, and then in the next video we'll talk about maybe nonlinear systems or some other concepts related to solving equations. Okay, so till then guys, practice these things, and if you have any questions, feel free to ask me.